So in this video I'm going to explain the next arithmetic instruction, which is called as a INR. So the meaning of this instruction is increment content of register or memory by 1. So here where it is used, this instruction is basically used for counting purpose, or this can be used in the loop while doing the programming. So here first of all we will see their opcode. Their opcode is here as a INR, and their operand will be register. So this register is 8-bit register, or we can use here as a memory location also, or memory also. So here we can understand their functionality with the example. So for example, we can take it here as a INR D, and let the content of this D register is here as a FFH. So first of all, this increment D means here it will increment the content of D register by 1, and after incrementing, the result will be stored into that register itself. So whatever here, if I had taken this D register here, so first of all, this processor will take the content of D and will increment by 1, and after incrementing this, it will store the result into the same register as a D here. So how it works, we'll see now. So here this D can be written, this D content, it is given here as a FFH. So in terms of binary, how we can write it here? 1 1 1 1, then this is 1 1 1, and here it should be added with what? This value, whatever is the value of this register content or memory content, so that values will be incremented by 1. It means whatever is the content of this D register, here we need to add 1. So now we are adding this. So 1 plus 1, sum will be 0 and carry will be 1. So in the second stage, 1 plus 1 plus 0, so sum will be 0, carry 1. 1 plus 1 plus 0, sum will be 0, carry 1. 1 plus 1 plus 0, so sum will be 0 and carry will be 1. So again 1 plus 1 plus 0, sum will be 0, carry will be 1. And then 1 plus 1 plus 0, sum will be 0 and carry 1. So here this 1 plus 1 plus 0, sum will be 0, carry 1. And again in the last stage 1 plus 1 plus 0, so sum will be 0 and carry here it is generating 1. So now we have to understand this mechanism. So how the increment it is happening. So for example, this is connected in the cyclic way. For example, if it is having 0, so after 0 it is coming 1, after 1 it is coming 2, and again after 2 it is coming 3, and again going to 0. So if we are standing at this point 0, if we will increment 1, then it is going from 0 to 1. Again from 1, if we will increment by 1, again will goes to 2. If this 2 is incremented by 1, it will go to 3. Now if 3 is incremented by 1, there is no way to go to 4 because it is in the cyclic way. So this increment operation, whatever it is happening, it is working in the cyclic way. So after 3, if we are going to increment, it means we are going to occupy the next place, so that is called here 0. So in the similar fashion, for the 8-bit of the register, this is their highest value. So if we are adding here 1, it means here it is, for example, if it is FF here, so after FF it will goes to 0 0 only. So that is the reason the result here obtained, it is 0 0. So here it is not, this D register is having the size of 8-bit. It cannot accommodate 9 bits here. So that is the reason after the execution of this instruction, so here I can say that this is the value before the value of D is FF, and after execution of this, D value will become 00H. And here if this carry bit is coming here out of this 8th place, then this should be ignored. This should be ignored, or we can say that it should be reset, because the reason behind that, it is working into the cyclic way. Cyclic way means 0 after 1, 1 after 2, 2 after 3, and again if it is cyclic to 0, then again from 3 to 0. So in the similar fashion, if the value is 0 0 in the hex form, then it will go to 0 1 0 2 and so on up to ff. So after ff, if we are going to increment, then it will goes to 0 0 only. So that is the reason the result stored in this D flip-flop will be 0. And here how these flags will be changing. So this flag will be changing as like, if you will find out here, this sign bit is 0. So this will be here 0. Then this entire 8 bit of the result, it is coming here 0. So 0 flag will be set here. Now if you will see that auxiliary carry, it has generated from this 4th stage. So auxiliary carry will be 1 here. Then we'll check it about the parity. So the number of zeros in this result is even, like the number of ones here, it is even. So we can say that it contains zeros number of ones, so that 0 is called as an even number. So parity bit will be 1, and for the carry bit, it should be no change. No change. So before execution of this instruction, whatever was the status of the carry, it will be carrying the same. It is not going to alter this. So here in this analysis, if the carry bit is generating in the addition of this value, or whatever we have the value of D, if it is incremented by 1, so if any carry is generated here, it should be discarded and carry should be taken here as a 0, or whatever is their previous value, it will be carrying the same. So here that is the reason that we can say that this only 4 flags are showing. These 4 flags are changing or modifying to reflect the result, and for the carry, it should not make any change. So this addition should not change over this carry flag. This addition operation should not make any change over the carry flag. The logic, the reason behind that, this is working into cyclic way. So that is the reason this carry flag should not be affected. So now if we talk about the size in byte, then if you see that this increment D is having only English alphabet, there is no 8 bit of immediate data. So here it is called only 1 byte as a size. So this is here 1 byte, and their machine cycle will be only 1 machine cycle, because this D register and incrementer, this addition operation, these all the things is happening inside the processor. So outside of the processor, it is taking only opcode from the memory for the execution of this instruction. So that is the reason it is accessing only one time of the memory chip. So that is the reason it is called, it is having only 1 machine cycle, and that operation is called as a opcode fetch operation, and it requires by default 4 T state. So the number of T states will be 4 here. But now the things will change if we are taking this with the operand as a memory. So now if we are taking, for example, if I am writing here INRM, and here if this HL pair is having the content of, if this HL pair is having the content of 2075H. So in this memory chip, whatever is, this is the address of this location as a 2075H. So whatever is the content here at this place, let's say as a 25H. So what this instruction will do, this will take, during the execution of this instruction, what it will do, it will take this data from this location, like from the 2075 location, whatever is the data as a 25H, it will comes to the processor, and by the use of this ALU and other part of the processor, it is going to increment this 25H by 1. that will become 26H, and after incrementing it will store the result at the same place. So here if we are talking about this size, then it will be having only 1 byte. With respect to size, it is only 1 byte, but now the things will change with respect to machine cycle. Why? The first machine cycle will be opcode fetch, and during this opcode fetch, processor is knowing that the operand which need to be incremented is outside of the processor, that is in the memory, which is pointed by before execution of this instruction what is the content of HL as like 2075H. So that will become the address of that particular location. So processor will fetch the data from that location as a 25H, and here this processor will increment this by 1, and then again it will store at the same place. So here if someone will ask about that, before execution of this instruction the content of 2075H will be 25H, and after execution this content at this address, this content will become 26H. So by this way it is performing this operation. So one machine cycle is opcode fetch, then again to read this from memory to processor, that is called memory read operation. After incrementing, again microprocessor is sending back to memory to store the data into the same location. So that process is called as a memory write. So how many times microprocessor is accessing this memory chip, that is called machine cycle here. So it is accessing 3 times. What are those? So first one is called as opcode fetch, means the opcode for this INR M. After execution of this INR M, this processor is knowing that the operand must have to come from where? From the memory. So that is called memory read operation. Then again after incrementing this 25H and that will become as a 26H, so that 26H will be sent it back from processor to memory. So that operation is called as a memory write. So as we know that for the opcode fetch, this is required 3 T. For the opcode fetch by default it will take 4 T state. Then for the memory read, here it is 4, here it is 3, here it is 3. So 4 plus 3 plus 3, it will take total 10 T states to execute this instruction as a INR M. So we should be very careful while doing this. Now what will be the changes over the flags? So as per this operation, means after performing 25H plus 01H, whatever will be the result as a 26H. So accordingly these bits like this flag sign 0 auxiliary carry parity bit is going to reflect, or it is going to be modified as per the result obtained by this 26H, and there should not be any changes over the carry flag. So here we can say that in the note you should write this point, that all the flags except carry are modified to reflect the result. So this is the very important point you must have to remember, because before of this whatever we had seen, the arithmetic instructions, then subtraction instructions, so there we had seen all the flags was modified as per the result obtained. But in this case, particularly in this increment instruction, only 4 flags, that is called sign, 0, auxiliary carry, parity, will modified as per the result obtained after incrementing this. Carry is not going to be changed. So whatever will be the status, it will be same here. So while doing this calculation also, if there is any carry generated, we have to discard that. So I hope you have the clarity about how to get the machine cycle for this INR-D and INR-M, and how it is different with respect to machine cycle and T states as well as their functionality. So I hope you understand all these points in better manner. So thank you for